Hello, and welcome to PPO's headquarters in Waterloo, Ontario, Canada. My name is Jamie Poholko. I'm one of the customer success managers here at PPO. Today we're in the production facility where I'm going to walk you around the Z-Config PPO Smart Imaging System. This smart imaging system is ideal for products that are fresh, that are whole muscle breast, trim, and other things that you want to inspect both sides of the product. First thing I want to talk about and show you is the HMI, or the human machine interface, that your operations team will use on a daily basis to interact with the machine. It has an image of what the machine looks like and feedback for the operator on what the operation of the system is. We have buttons on the machine so that your operations team can quickly and easily get this machine started in the morning, from resetting safety to start operation. The HMI also has a stack light to show the current operation of the system. So if it's green and yellow flashing, it's not ready for its work quite yet. It will show a red light as well when it's in a faulted state. So you're not only getting a visual that you can see on the HMI, but you're also getting a visual from further away from the system. There's the pneumatics enclosure, which is right below, is the location for lockout and tagout point to keep your employees safe. Pretty much everything on the machine has been designed to use common industry standard and high performing pieces of equipment. So we use Festo for all of our pneumatics. The main dump valve is here in this enclosure, and the rest of your valves for the rest of the pneumatics is found on the leg of the system. We have the rejection mechanism. We also have the calibration arm pneumatics, and we'll show that to you in a few minutes. I'm also going to talk about the drive and main disconnects. So your operations team is going to need to interact with the machine and get inside of it on a daily basis to make sure that the optical path is clean and the machine can do its job. We have a drive disconnect to protect your employees, making sure there's no power going to any of those drives, which is also a lockout tagout point. The main disconnect shuts off power to the machine. We also have inside of the system a UPS. So in case there is small power outages or some brownouts in your facility, the machine will stay operational, keeping the computers, the PLC, and all the low voltage equipment operational, speeding up return to production time. I'm going to open up the machine now to show you some of the interior components, and we'll talk through. You see two big boxes. This is the magic of the PPO Smart Imaging System. This is where our spectrometer and visual camera is, and the system is designed in such a way and sealed so that even the best sanitation teams can't get water into our equipment. You'll also notice hyperspectral lamps. These are what are going to illuminate the area of the product and allow our system to perform at its peak ability. We have a clean in place system that's piped directly in, so your sanitation teams or operation teams can rinse out the system before a full sanitation cycle. The sanitation features of the system are quite extensive. We have roll back side guides. We've also put belt lifters in to make your sanitation job a lot easier for your team so that they can access all of the difficult spots for product to get into and to clean, so team can easily lift up the belt, clean inside. We have a lot of other sanitation features that we've added in. One of them being this drip tray to make sure that the product isn't getting dripped on all the time. We have the clean in place that I've talked about before, with nozzles that clean out your Interroll motors. Interroll is a brand that we've had extreme success with and has wide adoption throughout the industry. This is one of the reasons we chose them. There's a bunch of other aspects that I'm going to talk about on the other side once we start looking inside of one of the detector modules, and we're going to look at the calibration of the system as well. So before we do that, I'm going to close up the doors, and we're going to take a look up top at some of the electronics that are controlling this system. I mentioned earlier that we use a lot of industry standards, ABB, Allen Bradley, and I'd like to show you those now. The system is equipped with locking mechanism that is sanitation friendly, keeps water and everything outside of the unit. We use a Ratal key, which is also another widely used system. So when we look inside here, we have our VFD drives, we have a UPS lockout tagout point, we have all of our breakers for our system that control the electronic lamps and other pieces throughout the machine. And on this side, we have the PLC. We also have switches because we are connected to the machine 100% of the time so that we can remote access your equipment in case of time of need or to minimize any kind of downtime. You'll notice ABB safety circuits. Each of the safety doors and the e-stops are connected to that safety circuit. So you can rest assured that if the system has a safety fault, it's not going to allow your employees to get hurt. Now, I'd like to continue our view of the machine, and we'll continue our walk around. On this side of the machine, I'm going to open up the detector module to show you the hyperspectral camera and the visual camera. Both the visual camera and the hyperspectral camera take images that are used and processed by our machine learning and AI algorithms. As you can see, there's 4 locks on this cabinet, keeping out all water and making sure that the optical path is kept dry and clean. Inside on the bottom, you can see that we have the hyperspectral camera, and perpendicular to it, we have the visual camera. The system uses, as I said earlier, both images in detection. There's also a clean in place plumb location down here where your maintenance team will connect it into the system so that you can clean off and loosen up any debris that gets caught inside the rollers on the backside of the belts. Let's take a look at the computers and the active cooling that's up in the cabinets above. The upper cabinet of this Z-Config smart imaging system has computers, power supply, and UPS. The UPS is used when there's an unplanned loss of power in the plant. It maintains power to your PLC, HMI, and computers, minimizing the downtime when power is restored. There's also a 120 volt DC power supply providing power to your hyperspectral lamps. This maintains an even and consistent power source to the lamps so that you can maximize your detection performance. The 2 computers on the left, one for each detector module, collect over 10 terabytes of information every day. This control computer manages the communication and the data transfer between the computers and the detector modules. The detector modules send the information up to the computers, they're processed, and a decision is made about a foreign material event within a fraction of a second. On the other side of the cabinet, we have active cooling. There's pumped glycol or water cooled into this heat exchanger, maintaining a nice ambient temperature inside of the control cabinet, inside the detector modules, because all of these components create a lot of heat. We need to manage that heat and manage the temperature inside to ensure optimal performance. The system is sealed, again, like I've said before, with Ratal seals and keys to maintain a watertight environment. Now let's turn the machine on and I'll show you the calibration and operation of the system. Before we get there, I want to talk a little bit about the rejection mechanism. The rejection mechanism is a full pullback rejection mechanism that rejects about 6 to 10 inches of product. Many of our customers use a takeaway conveyor to inspect that rejected product. And one of the other features of the machine is that we can adjust the distance between the conveyor 1 and conveyor 2 for different product heights. We have an adjustable knob that changes the height here because of the different products. So when you're running full butterflies or full trims, other things like that, you're going to need a different distance here. You'll see when the product comes here, it flips 100% of the time here onto the second belt and then is taken away down to the second detector module for imaging. You've probably noticed we have a lot of 4 emergency stop buttons highlighted in green to say that the safety circuit is happy right now. When you need to stop the machine in an emergency situation, there's 2 on the front on the in feed and 1 on the out feed. When you push the button, you can hear the safety dump of air and also reset of the safety circuit. So until you reset the safety circuit back at the HMI, which we'll do in a moment, there's no power going to any of the components. So I'm going to reset that safety circuit. We also have an access door on the side of the rejection mechanism, so your sanitation team can get in there and make sure everything stays nice and clean. Let's go over to the HMI and I'll show you the different faults and ways your team will know if the machine has a fault or needs attention. So on the top of the stack light, it's now red. So you can see this from many different places throughout the room. Across the HMI, you have a big red bar saying there's something up. It tells you what issue happened. This is telling us that the e-stop at the outfeed was set. You also have a red button on the reset of the e-stops that shows that there was a fault. I'm going to close this. I'm going to reset my safety circuit, reset my faults, and I'm going to turn on the conveyors and lamps. So this is what the machine looks like in its normal operation. Product is going to flow from the in-feed side of the machine, get scanned by the first detector module, get flipped over, come down the second conveyor, get scanned by the second detector module, and then onto the out-feed belt. And then if there is a foreign material detected, then it's going to reject at the rejection mechanism. One of the real critical pieces of detection with a vision system is product presentation. When product enters the machine, if any part of that surface is hidden, then that's an opportunity for a foreign material to hide away from the machine. So single layer, putting products not overlapping is a critical component to really good detection. So I'm going to trigger calibration now so that we can start scanning. So it asks you, sure you want to do that? You click yes. Now, the lamps need to be in a steady state before calibration can take place, where you have to wait a little bit of time, making sure that there's a minimum of 90 seconds has elapsed from the time the lamp's turned on to the time the calibration begins. So once that is complete, you will see the calibration arm will swing down. The cameras are going to take images of that white bar and then use that to adjust and optimize for detection. After the calibration is complete, it's ready to use for scanning your products. PPO Smart Imaging Systems are used in RTE, harvest, and secondary processing plants in chicken, beef, and pork. And it's ready for your plant too. Check out our other videos, and we look forward to working with you.